All right, so this is essentially part 3 for Team B, and I think we're at part 3 for Team A as well, actually. But I'm actually going to make this more dedicated, really just towards both teams. In fact, I'll probably label it that way. But I wanted to cover first how to size this the right way, because we do need it to be an exact fit, right? I mean, that's kind of the point of even using some of these devices, is that what we actually produce in the digital realm, we do want to be able to physically model that. Otherwise, it's just, I don't know, a hypothetical. It's just stuck in a computer realm, if you will. And in fact, I think that's where it actually starts to get really unique, is that we can build stuff in this digital realm to actually help us. However, easier said than done. But in our case, like I mentioned, for Group B, or sorry, Team B, this portion is due Wednesday, right? Arguably, I could almost say the same thing for Team A, but we have different requirements. But in our case, you probably remember how we sized this up, and we essentially just took it to the laser cutter, right? So we took this piece, made a copy of it, already has the hole in it essentially, but I need this measurement, and actually, if I'm not mistaken, I think I just arbitrarily made that square, right? Now, ideally, it would have been a better idea to actually set it to like 32 feet, 33 feet, doesn't matter. As long as I know that dimension, I could calculate what that is at 1/8 scale. However, I just can't calculate a random square. So I unfortunately did a random square. So if you did a random square, this is a way to essentially get out of it. But in our case, we need to size this to 1/8 first, because mine is arbitrary. Now, if you already have yours, you can kind of skip to a later on step. But in our case, I'd want to take this piece, go to my top, and just like I did for my laser cutter, I'd want to get my rectangle at the scale of the printer. So in my case, a 12 by 24. But if I type in 24 inches, enter 12 inches, I get actual size, which is good. That's actually what we need for the STL, but not what we need for the laser cutter. So in my case, for the laser cutter, I want to size that first by timesing it by 8. If you guys remember from one of the other videos, we did 8 times 12, which is 96. So in my case, I'll type in 96 feet, because I'm basically just changing those units. Oops. 96 feet. And by 2 times 96, so times 2, 192. So I've got that. Oh, let's try that again. 96 feet by 192. There we go. So there's that 12 by 24 ratio that I need to essentially print it. And since mine is arbitrary, I can basically move this, right? So for instance, there's a couple ways I can do this. I could just measure this, so DIM, dimension, take this point and the opposite point, and notice that it's 27.66 feet. Remember, this is why I should have just done 30, because that would have been easier to scale. Basically 1/8 times 30, right? And then essentially I have the model size that I need. In my case, it's a little trickier, but of course, hopefully yours is a little bit easier. In my case, the best way to do this one is to actually size it down to real life. So now that I have this at a 1/8 scale ratio, I can essentially take this whole piece, and here's a good use of group, right? So I'll take this, group it. I'll move my base edge to my same base edge that I made. Sweet. And I'll scale it. So scale. I'll select this as my base point, and I can really just select the other side of my 12 by 24. It'll make it real tiny. And funny enough, that's the actual scale that it is, right? Because the real one is actually the size of, well, a 2-story building, right? Whereas the real one is, of course, very tiny. So it really, I mean, I don't know if you guys have noticed, but this is where you really start to understand scale, right? Or how big or small things are, even in the digital realm. However, we found out that it's 0.29 feet, so if that looks awful, you can also change this to, obviously, feet and decimal. We'll switch it to inches and fractional. So we can get the actual measurement is 3.5 inches. See where I'm going with this, right? But that STL has to be exactly 3.5 inches. So don't get me wrong, I just did that so that I could get the measurement. right? And then I could verify that the measurement's correct. In fact, I would even go a step further. I'm going to delete this dimension because sometimes it gets in a kind of it ballparks the dimension, if you will. So I want it end to end. I'll take that line, if you will, that curve. I'll type in length. And I definitely want to verify, yep, that it's exactly 3.5 inches. And you can see it in this bottom corner right down here. So we verified that it's 3.5 inches. Now I could just take a copy of this, and I could just scale it down, right, to 3 inches. So in my case, 3.5 inches. I'll go ahead and draw 3.5, but as you can see, drawing 3.5 inches is gonna be like, what? It's gonna be kind of hard to see. So one of the things that I would actually do is very often, especially since I got a lot in this model, I'll take the piece that I want, file, export selected. You could do it as a Rhino 8, it doesn't actually matter. We just need to reopen it in a nice clean file. So in my case, I'm going to save it as an STL, STL fixed. 1. We'll put it on the desktop for now. Export, export. And I can actually open up that STL file in Rhino. So if I go to Rhino 8, open, go ahead and open up that STL fixed. Import. Now I can import based on now millimeters or inches. Now in my case, it's setting the units, right? So if it's 30 units, which in our case in the last file was 30 feet, it's going to set it to 30 millimeters. No big deal, at least it's not really big. Now we still need to get it to the right size. So in my case, now it's all clean. It's in a nice new file. So I don't accidentally get other pieces, or again, that could wreak havoc if you're trying to 3D print something and there's this piece way off in the distance that you accidentally got. It'll fail the whole model, right? Not that you guys should prepare for failure, but obviously want to help you guys in obtaining success. But in our case, it's looking pretty good. The next thing I need to do is scale it, and as we know, we need 3.5 inches, and that may be easier, of course, on this piece. So I'll make a rectangle, 3.5 by 3.5, so 3.5 inches. Keep in mind, if I just type in no inches or feet or anything, it'll do 3.5 millimeters, so be careful, right? It'll always default to that original piece. So 3.5 inches by 3.5 inches, and that is actually the size of my model. So funny enough, it actually imported it too small. Again, I want to take something known, such as this vertice right here. You'll keep in mind that, well, when it's a mesh, it actually only gets the vertex. You'll notice that some of these endpoints no longer work, so I've checked vertex, and that is true of a mesh. All right, so we've lined up one, scale, enter, and of course scale that other piece to the other side. Now this is the one that I want to export. Now it's to a true scale. Now it's exactly 3.5 inches by 3.5 inches. That's the one I want to file, export selected, and I can even rewrite this one, right? So I could stick it on STL fixed, but I'll name it number 2 and fixed, right? Or I should say scaled. There we go. And I could even say 1/8 scale. Awesome. Now that's the one I want to send to Formware or send to my professor. Now where do I send it? I went ahead and made an easier link on Miro. So you'll notice it's a part of our Google Drive. There's another folder in there. But I just wanted to point it out for everybody because there's nothing like I submitted the STL but I never got it and I never get to print it, and you know, that kind of issue. But yeah, you can click on here, it'll bring it up, and you can just drop it right in the folder and I'll get it, right? Keep in mind, if it's over 100 megabytes, you probably didn't do it right, or it's probably the wrong size. Keep in mind, it should be anywhere from like 25 megabytes to at most like 50, right? If you really exceed those things, there might be something just off about the model. So keep in mind, our free STL fixer, it's literally all you have to type in. You can go right to Formware. That's also on the Miro. So again, make sure that you're checking your meshes before you submit that STL. All right, so that part was really for both teams, obviously, to submit the STL model by no later than Thursday. So that's looking pretty good. I'll go ahead and close that for now. And I guess we could save it. STL scaling. That way I don't forget. Put in our documents. got way too many documents. Zach, computer graphics, summer, Rhino files. That's good. Save it in there. All right. Now to work on to kind of the next part of Team A. So I forgot this part when I was doing all that modeling and ran into, essentially all those errors. So I wanted to not rob you of, what else I wanted to show you. And potentially something that could go into your 3D printed model too, if you get that far. It's not an absolute requirement. And again, they're pretty ballpark requirements of this course. If you've noticed, it's not quite like a studio. I really just want you to understand the software. That way you're prepared, and that way you go, man, I know what I'm going to do in this class today, right? For Studio 1, Studio 2, you probably won't be able to use 3D printing, but in Studio 3 and 4, definitely encourage, especially in my class, especially in Chronodal's or Longoria's class. Longoria knows 3D printing pretty well too. But in our case, let's go back to Team A. Sweet. And really where we left off last time was just honestly some advanced modeling stuff, right? That way when we made 2D and we started making floor plans and clipping plane and all that stuff, that it starts to actually have something in it. But I forgot to show you some of the really cool places that we can go and import these models, right? So for instance, we talked about last time, like, okay, starting to develop that floor plan, that way I can actually make another model, right? But you'll notice in the next assignment that floor plans and sections are required. So you might actually want some scale figures already. You might want some stuff like cars, objects, other items that, let's face it, I don't want you to spend 5 hours modeling a car when we can just download and import one in nearly 35 seconds. However, I also don't want you to go to a sketchy website and accidentally download a virus or malware to your computer just because I asked you to put a model in there. So one of the best sites that I've ever found is called BIM Object. And I believe I have this one on the Miro as well, and we'll definitely use it for Revit because it is awesome for Revit. I would say probably more awesome for Revit than it is for Rhino. However, if you click on software here, you'll see that we have a Revit box and we got a Rhino box. Rhino's pretty sweet. I don't know, I need a cafe, I need an espresso. I may need some counters, I may need some tables, I may need some chairs. And don't get me wrong, you can go Frank Lloyd right on me and design the whole thing like Falling Water, or you can just go find some, right? And to be completely honest with you, in the real world, we find them. Or a client goes, I really want these chairs, or I really want this unique refrigerator that's only made in Switzerland. Okay, well, let's go find it. Let's go find those dimensions. Let's go find the supplier. Let's go find how much it costs. Because eventually we have to put these things in our models. Now, the way BIM Object works is really great. The manufacturers, they make the models and they put it on this website so that you will pick it and use it in your project. That way it makes them money when the client has to buy it and put it in their project. But in my case, I'm going to switch to Rhino software. Let's type in, I don't know, table. And to be fair, you can do this with the doors. You can do this with almost any part, right? But for instance, you could actually use it as inspiration too. I don't know about you, but you might be thinking, man, I want a bench, but I want to design it myself. You can start off with a base bench and make it your own too. So, I mean, don't get me wrong, that takes more time. But yeah, if you were ever like, man, I wonder if a triangle, side table exists, bam. Triangle side table, right? Or, whatever that is. Anyway, as you can see, there's a lot of tables, but I don't want you to get lost picking a table for an hour. Does that make sense? So, I mean, don't get me wrong, this is to help us save time, not get lost in the sauce trying to pick the right table. Let's face it, with the tools that we have today, I can make this a shorter or larger table in an instant, right? But for today, let's, that's actually looking pretty sweet. It's got that IKEA kind of look to it. You do have to sign in. It's all free. You can use your EDU or your personal account. To be fair, I forgot which one I used. Let's see. Cursive piece, maybe? Continue? Actually, I think I used my Crabapple Designs. All right, there we go. So download, in my case, this is where it'll get tricky. I don't necessarily want a DXF file. If I was in AutoCAD, DXF would be really good, or if I was laser cutting, DXF is pretty good because it's a flat two-dimensional file. Same thing could be said for DWG. That's an AutoCAD file. You guys already know we can use a DWG in Illustrator or just about any other program. But the one that you actually want is an object file or a 3DS. 3DS will sometimes work, but 3DS is more like a three-dimensional scene. That's what the S in scene, 3DS stands for, is a three-dimensional scene and an object file. If this is absolutely confusing you, welcome to the digital realm of file name extensions, right? PDF. Can anybody tell me what a PDF stands for? I look it up every semester and I forget every semester right after I look it up. But extra credit out there, right? Tell me what a PDF is. There's actually slang for a PDF now. Anyway, maybe not, right? It's what we call, I shouldn't say this on a YouTube recording. Anyway, in my case, let's go ahead and download one of them because it is going to automatically download all of them. So be careful. Make sure you enact the one that you want. And then, of course, download selection. In my case, I'll save it to my downloads. Make that a little bit easier. Now, you can just import something. So you can type in import, or you can usually just drag and drop it, by the way. So in my case, import, I'll go to my downloads. And in most cases, the download actually saves as a zip file. So you may have to decompress it first. So we'll go to, oh, there it is, object. In my case, I'm just going to drag it right in. Oh, but I'm already in a command, so, oh, there it is. All right, let's bring it in. Usually you can kind of just default to what it is, but to be fair, yeah, there's definitely some options. In my case, I can import the object as a nothing, as a layer, as a group. I'd really recommend if it's a very complex object to group it in, just like we make 2D. In my case, I'm just going to go with the default settings and see what happens. Very often, whoa, the world's largest table, right? Because it's based on those units, right? Just like what we just did with our STL model. Now, in my case, that's a good start, but I'd probably want to make it facing right up. It also looks like it came in with, some extra pieces. Did I make those?
Yeah, you made those.
Oh, okay, good. I was like, damn, what the hell is that? Anyway, let's hide that for now. And let's hide some of my other stuff. There we go. But yeah, fake it till you make it. Whoop. So let's make that, of course, a lot smaller. And we'll give it a dimension. Obviously, I kind of want to get it into a ballpark situation. So let's get it at least close. And after all, I might need to do this actually in my top view, so I can see it a little bit better. And wow, I've got a desk the size of my architecture. I tell you, the funny stuff we can do. But now I do have a desk, and well, it's still kind of arbitrary, right? So I would want to identify that, and actually now that I look at it, my structure is enormous, but that's okay. I'll go ahead and do a dimension, just because I kind of want to see how big that is. Holy 273 somethings. Boop. Oh, it's in millimeters. Well, that'll do it. Let's go with feet and inches. There we go. All right, so 10 inches, not too bad. Although a typical desk is anywhere, 6 feet by 3 feet. I don't know, let's get one of those dimensions. So I'll draw a line, 3 feet, enter, just to give myself a ballpark scale. I'll take my base point, and again, I'm like rough balling it here, right? So again, now we got our dimension table. Now, as you can see, I need a lot more space in my architecture, but hey, now I've got some furniture. And as you can see, that's not exactly something I wanted 2D, right? So be very careful about this and just suddenly filling and populating your stuff with stuff. In fact, if you were just doing floor plans, you might just want the DXF. So let's show you what I mean by that. So let's go ahead and get the DWG instead, and well, let's see if it's any different. If I get all those triangles, because usually if an object comes in as a mesh, and eventually you really start to build a repertoire of what each of these file types are for or what they do. DWG is often for only two-dimensional, so that was kind of my next giveaway. So let's import again and get that DWG. Another reason why AutoCAD is so awesome is literally you can get any file type, and as you can see, better, and really arguably the exact same file, right? So a DWG can be three-dimensional. It's not often that it is, but if this was the case, it's the exact same file essentially. But let's say I do need something a little bit more. I mean, don't get me wrong, that makes a great rendering, right? And I can definitely use it for rendering. I could even start to kind of feel and set up, maybe even set up with a client, like where the furniture and things go. After all, you're the designer. You should tell them where it goes, not them. But in our case, I may want something a little bit simpler for my floor plan. So for instance, I can take that object. Let's zoom into that a little better. We'll make 2D. And let's see what it gives us. Very often it takes away those lines. And there you go. All right, so even when we make 2D something, it is going to overall simplify it. And arguably, maybe almost too simplified if you ask me. I don't know, maybe I'd want to keep in some of that information. So for instance, maybe I take the hidden lines. And you know what? Instead of doing this over and over again, let's just put that stuff over there. Make 2D. Let's maybe get some of our, oh, it did have hidden lines, all right. So not sure what's going on there. Let's maybe viewport rectangle, nah. Group output, nah. I may have to just draw some of that stuff. Let's get some of this over there though. I have to keep flipping over. Oh, it did get it. Actually, I know something. It's the tricks they don't tell you in school. I guess until today. You can also flip something over and get a make 2D as well. So we'll take that object if you needed a make 2D, right? So I'll take that, take it from the top. See if that gives us anything different. Nice. So obviously we can still get some of that information, and then I would just change that to a hidden line, right? I could even get rid of some of the too much information. Maybe I just want to show certain elements. But I don't know about you, but it beats the heck out of drawing this every single time I need a desk or a chair or an item. Now let's talk about some of the harder objects, which is usually equipment. So let's get some equipment in here. Or chairs. Honestly, that's another one that gets a little funky because there's a lot of geometry in chairs, I'm not gonna lie. Rhino, search. Oh, there's a search bar. I'm thinking coffee. I mean, if I'm doing some sort of cafe, I'm gonna definitely have some sort of coffee machine. Now, again, you can kind of ballpark this. Again, I'm not expecting everybody to suddenly know what goes inside of a kitchen, but a dishwasher, a sink, those kinds of items, some countertops, all kinds of stuff. And one thing that I would look at is probably another cafe. So for instance, if I didn't know what a cafe was, one of my favorite websites of all time, Pinterest. Or just, I'll show you how to use AI a little bit better. Perplexity is definitely my favorite, just because it uses basically every other model. And if you have your EDU account with Alamo, it's free for a year. You can get pro version. You don't have to pay $20 a month. And I think it actually resubscribes every year. Don't tell anybody, because I hope they don't fix that. But in my case, floor plans of a cafe. I use it really more or less as like a Google search, just a better one, right? So not really trying to solve anything for myself, but just to kind of show you the differences of, say, a cafe floor plan versus, you know, I would go with something, guys. Now, you don't have to copy this, but let's face it, you got to teach yourself in college. That may be the unspoken rule of really higher education, is that often you realize I facilitate these things, but at the end of the day, it's just impossible to teach you every single thing that I know. But one thing I do know is that in school, I definitely looked to others. I looked at other cafes. I went to Press Coffee on Broadway and realized, wow, this is a very different way to experience coffee, right? So you may have to go out, do some research. You may have to look at some pictures. Perplexity, another great one. It will start to utilize some of these things. I mean, don't get me wrong, we could check this out. But for instance, it even gives you some of the architectural elements, such as key heights, customer queue, two-person cafe table, and really some just basic dimensions, guys. So I don't know about you, but damn, I wish I had AI when I was in school, because this is often what I was just Google searching anyway first, right? So now it's a Google search away, and even better, if I click on links, it gives me all the links that I would have got and where it took those from. Do not use ChatGPT. It's not good at sourcing things. Perplexity is far better. In fact, you could even switch it to ChatGPT, right? Or Sonar, or Gemini, or Claude, or GLM, or Kimi, or NewMotion, all for the same price. Again, I'm not getting any money for this, but I should, because I really talk about this too much. It's a really great resource, and if you're kind of in the same boat as I was about a year ago, like, man, which AI should I use? Perplexity. It's free and doesn't kill a bunch of trees or waste a lot of water. In our case, let's do it, right? So I may need to look at the kitchen itself. I don't know, cafe kitchen, floor plan. Do some research. Even if that research is a simple Google search or Pinterest search, you got to start somewhere. But it's a great start, right? And as you can see, really starting to learn a lot more about a cafe situation. Now, the same thing could be said for an art supply store, right? Now, don't get me wrong, art supply floor plan, I don't know, you're not going to get a whole lot of results. Cafes are definitely much more popular than art supply stores. You may have noticed we've got literally like sometimes a Starbucks within 100 feet of each other versus an art supply store that is constantly dwindling even in San Antonio, which hence the project. But in our case, let's do it. Art supply store. And let's see the varying results. Floor plan. So don't get me wrong, I may have to do some research and go, hey, what's an easel? Does anybody know what an easel is? Holds up an art supply, but not everybody knows what an easel is or how to draw one in floor plan, am I right? So again, we want to ballpark it in some way. We either want to find those objects and almost put them on display, or fake it till we make it diagrammatic, and maybe make a rectangle that's dashed that goes, here is where I want you to buy easel supplies. Does that make sense? Anyway, but I would find a plan, guys, and stick to it, right? Obviously, we can get scale figures. So another thing that we can do, and another wonderful website, is DWG downloads. Floor plan. Free CAD floor plans. You can actually get the entire DWG, whether it's a house, whether it's, again, I'm not saying just copy these. I can't stress that enough. But my goodness, I wish I had something like this while I was in school that I could look to, that I can go, why did that architect, why did that designer use this? I could even bring it up to my professor. Hey, why did they use this versus that? Well, this one is in Canada. This one's in the United States. Of course they're going to be different. Of course one's going to be in metrics, one's going to be imperial. But you learn so much, guys, from, of course, looking at other projects. So I just wanted to stress that enough, right? However, I don't want to take up too much time today. This was really just kind of an add-on for Team A, right? Because I forgot to go over how to basically import some of these models and things like that. Keep in mind, you can do this with the doors. You don't have to model your doors or windows. However, I would highly suggest it, because manipulating a door and window is a lot harder than it looks. So I don't want to get too advanced on you guys today, but keep in mind, our site model is essentially due Monday of next week, right? So hence getting that STL by at least Thursday. However, for my Team A, don't let me stop you. I'd start making the floor plan. I'd start looking at the section, and I'd start using those pieces just like we talked about last time in order to continue making a nice model. Don't get me wrong, I'll print your mass model, but would definitely prefer something closer to, I don't know, a study or a final model. So keep that in mind. Otherwise, any major questions, guys, over these parts? How to export that STL at the right size or to import anything? Making some sense? I know it's Monday. Hang in there, guys. All right, we'll end it there for today.